Hi, we are team number 5 and we have to solve different procedures to get the answers for the next equation.
Our equation is 2 squared minus 4 over x squared minus 1. The first step is to find the restriction and the domain. So we use this to have the domain, and we isolate the x, and the result is this. And the restrictions are x can be 1 and x can be minus 1. So the domain is x belongs all reals except minus 1 to 1. Okay, the second step is to find x and y intercept coordinates. And when x you need to equal to 0, so you have this multiplication with 0. The answer is plus less 2, and the coordinates of x intercept are 2, 0 and minus 2, 0. And y intercept you need to put 0 on x. So the answer is 4, and the coordinates of y-intercept is 0. We need to find the symmetry of the function. So you change all the x's with minus x, and the result is the same as our function. So x equals. You need to find vertical asymptotes and their paths. So to find the vertical asymptotes, you need to use the denominator and equal to 0. So there is a vertical asymptote in x equals to minus 1 and in 1. And there is no gaps because there is no simplified.
We have to obtain the horizontal asymptote and use the limit x to infinite, and use the case 3 to obtain 1 over 1 and this 1 and this horizontal asymptote in y equal to 1. We have to calculate the first derivative of the function, and we use the quotient rule of this formula and obtain this and simplify the equation, and this is the first derivative. In this point we have to calculate the IPTs and the first derivative and the increasing and decreasing intervals. We have to equal the first derivative to 0, and then isolate the x and obtain x equal to 0, and the minimum point is 0,4, and then we have to calculate the decreasing and increasing intervals to minus infinite, 0, and 0, infinite, and we have to substitute x to minus 2 and 2, and we obtain minus 4 over 3 and 4 over 3, and is decreasing and is increasing because the sign is negative and the sign is positive.
Now for this part of the project we have to start solving for the second derivative, and we have that the first derivative was this. So we just have to solve for with our quotient rule, including the chain rule. Why? Because we have that it is a denominator with an x and numerator with x. So we just have to start like this. Now that we solve it, we just start to simplify and solving for this part of the chain rule, and we start doing this. Then we get to these steps. In these steps we have that this and this are the same, so we can take, and they are multiplying, so we can take one part of this. So after that we have this, and after that we just need to keep solving until we have this result, and this result is the second derivative of our function.
With the second derivative of the function, we equal the second derivative to 0, isolate the x and obtain an imaginary root. So there are no concavity.
We can conclude that a simple function can have a lot of data which we obtain in this project. This information used can work to know the position of the above mentioned function in the graphs and to obtain the derivatives, which help use to see across the slope, the evolution or the change of physical phenomena.